Hi everyone, we're going to talk more about causal mistakes. In particular, we're going to talk about a phenomena that leads people to attribute causation called regression to the mean. You can read about regression to the mean in Daniel Kahneman's book, Thinking Fast and Slow, chapter 17. All right, so because of our evolutionary background, we are conditioned to see causal connections all over the place. This makes us excessive causal theorists. This is because figuring out what causes what in the world is very important for survival. And over-attributing causation, being an excessive causal theorist, so this is attributing more causal connections between things in the world than there were, was not something that was harmful to us, but under-attributing causal connections would be very harmful. So our early ancestors needed to quickly recognize anything that's dangerous in their environment. So let's take two cases of red berries causing pain and death. So suppose that you're out in the woods with your caveman friend, and your caveman friend finds a bush with some delicious looking berries, and you've never seen these berries before, and your friend eats them, and all of a sudden after that your friend drops dead. Now, coming to the conclusion that the red berries caused the death, so that first you have the berries, then you have the death, therefore the berries caused the death, is the safest conclusion to come to. So suppose the berries were poisonous. Believing that the berries cause death will keep you safe, will keep you from dying. Now suppose the berries were not poisonous. Suppose that the berries were perfectly fine, and what caused your friend to die was the bad water that he had 48 hours ago, and finally it just caused the stomach pain and death. So suppose it was just a coincidence. What's the worst that would happen to you then if the red berries, if you are over attributing causation? The worst that could happen to you is that you're missing out on some good berries. So that is not as bad. Not getting to eat the berries is not as bad of an outcome as eating the berries and having them cause you to die. So over attributing, so suppose the berries are perfectly fine, jumping to the conclusion or concluding that the berries cause death, the only bad thing that comes out of that is you don't get to eat the berries. But suppose the berries are poisonous and you don't make that causal connection, you end up dead. So you can see how, as a general policy that nature could adopt to make our species survive, attributing these causal connections between bad things and good things in the world keeps us alive. And over-attributing these causal connections do not have as big of a drawback as under-attributing them. And here again, saber-toothed tigers causing death. So suppose that you are in your camp and you know that your friends are out in the meadow, and you hear screams, and you go to the meadow and everyone's gone. If you say, hey, I wonder where they went, and you don't put together first saber-toothed tigers were seen in the area, then you heard screams of pain, then your friends were gone. If you don't put together the saber-toothed tigers probably caused your friends, you're going to be cause the death of your friends, you could be in big trouble in the future. So it's really good to notice that connection between the saber-toothed tigers being present and your friends screaming and vanishing, even if it was just a coincidence. So it's better for us as humans to over-attribute causation as a means of survival. As a policy, it helps us to survive. And this has led us to be excessive causal theorists. Okay, so as humans, we have a high false positive rate for causal connections. So false positive means believing that there's some positive connection when there really is not. Okay, so again, just to repeat, overestimating causal connections isn't costly, but underestimating them can be deadly. So for instance, here's an example of an overestimated causal connection, or a false positive causal connection. Some of your ancient ancestors perform a dance, and all of a sudden it starts raining, and they believe that these specific dance moves have the power to bring the rain. So their dance moves cause the rain to come. Believing that is not going to kill anybody, but failing to believe, to see the person who ate the red berries and seeing that they died afterward, that could potentially have fatal consequences. Okay. Now, because that this is our evolutionary legacy, we are conditioned to see many more causal connections in the world than there really are. So much of what we think is cause and effect is really just random, is coincidence. For example, my husband always says this. He puts his iPod on shuffle, and he'll say things like, my iPod really likes this music today, or when really these are just random picks. Our mind is just conditioned to see these patterns. We're conditioned to see causal connections, to think that the iPod really likes one music group more than the other. Okay, so here's an example of an over-attribution of causation, a post hoc fallacy, where the mechanisms behind the scenes, or what's going on behind the scenes, is really something called regression to the mean. And it's called the Sports Illustrated cover jinx. So for years, sports enthusiasts have noticed that an athlete will appear on the cover of Sports Illustrated, and then shortly thereafter their career will have a dramatic fall off. So they'll do really, really well, they'll be at the top of their game, and then the next year, right after they appear on Sports Illustrated, they'll get injured. Or so here's an example, Tim Tebow. Here's a cover of Sports Illustrated. It says he's amazing, incredible, phenomenal, mind-blowing, incomprehensible, and unbelievable. Where is he now? He's not even playing football. So this has led to something called the Sports Illustrated cover jinx, or cover curse. And athletes were beginning to refuse to appear on the cover of Sports Illustrated because they thought that being on the cover of Sports Illustrated was causing their poor performance. So, and this is post hoc, so appear on the cover of Sports Illustrated. What happens next? Bad performance. Therefore, what caused the bad performance? Being on the cover of Sports Illustrated. So this is an article here. This is a real Sports Illustrated cover. It says the cover no one would pose for. Is the Sports Illustrated jinx for real? And you can actually go on the Sports Illustrated website, and they have a log of all the covers and then what happened right after, from multiple years. Okay, so what's really going on here? It's something called regression to the mean, and let's just skip through that. Okay, so what is regression to the mean? Well, first of all, we'd have to know what the word mean means. What is the mean? What does mean mean? It means the average. Okay, so for any sort of quantifiable property, you can find an average or a mean. So anything, height, weight, grades, income, GPA, the population of a city, the numbers of people with different party memberships, the number of free throws. So you can find an average. What's the average number of free throws this person sinks? What's the average number of minutes you take to run a mile? How much weight can you bench press? I don't know. The seconds you balance on one foot. The number of golf strokes it takes to, what's your average golf number of strokes it takes to get a ball in the hole. Anything that has a quantifiable property can be averaged, and that's the mean. Now, what's regression to the mean? Oh, here we go. So the mean is often represented as something called a normal distribution, and the mean is often where most people, most performances, most IQs, most shoe sizes, most heights, most number of seconds you can balance on one foot tend to cluster around this average. So this is something called a normal distribution, and in class, we do a coin flipping exercise to show how random events distribute themselves in this sort of bell curve shape. And I'm going to show you this video because we can't flip coins and record the results online. So we're going to watch a video instead. Here we go. So what that video showed was a random process. So these balls are dropped from above, and they bounce randomly, and they distribute themselves in this normal distribution of the bell curve. So it's really interesting how randomness ends up this way. Okay, so what's regression of the mean? So we've seen what the mean is. We've seen what an average is, we've seen what a mean is, we saw what a normal distribution is. So what's this regression thing? Well, regression to the mean is a law, or it's a law of random statistics, is that things tend to gather around this average over time. So you have something that's way above average. If it's subjected to a randomness, to luck, it's going to tend toward this average. So most members of a set are here. See how much larger this area is under here than it is in here. So most members belong here. If you're an outlier, way above or way below, the odds are is that you will tend toward the average over time. So this is a natural process and can be expected to happen when randomness, chance, or luck plays some part in any process. So the first time that randomness was, or the first time that this was observed was in genetics, and there is some randomness, chance in as far as when genes come together, they come together randomly. So this was shown that if you've got two outliers, so two parents who are very, very tall or very, very large feet, or really, really, really short, their offspring will tend toward the average. So this was one that was first, a regression to the mean was first noticed in genetics, and the randomness is what sort of, what pairs of genes go together. Okay, so let's go back to sports. So the regression to the mean can be used to explain the Sports Illustrated coveragings. So Kahneman talks about success being, the formula success being talent plus luck. And great success being is a little more talent plus a lot of luck. So think about what it takes to be on the cover of Sports Illustrated. What does it take to be on the cover of Sports Illustrated? Well, you have to have a lot of talent, but there's also some luck involved, because think of all the other talented NCAA athletes this guy's up against. What's going to put him head and shoulders above the other very, very, very talented athletes? Well, some luck, and perhaps a lot of luck, to be one out of how many really talented people. So the luck ingredient of success is what's subject to statistical fluctuations. This person is very talented, but he's also lucky. And what's going to happen when that luck regresses back to the mean? Well, he can only go down. So he's an outlier as far as how he's an outlier. This basketball player, he's doing excellent. And statistically speaking, the most likely thing that will happen next is he'll go down a little bit. Will do worse. And that is just what statistics predicts. So it's nothing about the cover of Sports Illustrated that is making him. Being on the cover of Sports Illustrated is not causing any athlete to do worse. It's just a function of statistics. So here, a person who is on top of the world, this person, has nowhere to go but back down toward the average. So this is putting it a little too strongly, nowhere to go, but it's very likely, statistically speaking, that that people that are at the top of their career, that are on the cover of Sports Illustrated, will do worse the next season, just because of this law of statistics. So again, the luck portion of the equation is subject to these statistical fluctuations, and this luck will run out, causing it to appear as if this player has done worse. Okay, so here's another example of regression to the mean. Here we go. So Kahneman talks about this, a study, actually a fake study in chapter 17, where very depressed children are given an energy drink and they improve over a 3-month period. And Kahneman says that you can attribute the children's improvement not to the energy drink, but to regression to the mean. Why? Because depressed children are an extreme group. Here they are, they're way below average. And over 3 months, if you take a group of 100 children who are very depressed, over a 3-month period, they will naturally regress toward the mean. Now, I taught this last semester, and I want to clarify something. A lot of people wrote in their essays last semester that if a child's really depressed, don't do anything, they'll get better because children are resilient or something like that. Well, that's actually, saying children are resilient is actually a causal explanation for why children are getting better instead of a statistical one. But I don't want to teach that you have a depressed child and you don't do anything. You shouldn't do anything, they'll get better on their own. Out of a group of 100 children, as a group, if you average the results, so you take their depression scores first, and then later you take their depression scores again, as a group, they will regress. They will go toward the average. They'll get a little better. But that doesn't mean that there aren't some individuals in the group that'll get worse, and that doesn't mean there's some individuals in the group that might commit suicide. So I'm not saying that, as a rule, ignore depressed children. And there's another lesson to be learned by this. So you take this energy drink, you give it to depressed children, and look, after they drink it for 3 months, they get better. We assume that the post hoc again, the energy drink caused the children to improve. Now, if this study included a control group, we would know that it's not the energy drink that is causing the children to get better. So if one group were given Red Bull and the other group was given orange juice, and then the results were compared, you would see that there was no significant difference between the two groups, and it wasn't the energy drink. So this is also a lesson in the importance of having control groups in scientific studies, because the results can be misleading. Okay, so here's another example of regression to the mean. So Kahneman talks about how so this is a fact that smart women marry less intelligent men, and if you at the next party you go to, you say, hey, I heard this fact that smart women marry less intelligent men. Oh, why do you think that is? People will give you all sorts of causal explanations. They'll say, oh, Well, it's because smart women want to control the men, or smart women are tired of competing with men in the workplace and they just want to come home and relax. They'll give all sorts of different explanations. But what you won't hear, or you're less likely to hear, is a non-causal explanation, just a statistical explanation. And this is actually the real explanation. There are not very many very smart people. So only 2% of the population are very smart. And statistically speaking, it's much more likely for these few people to meet these people. So to be with, this 95% of the population. So what's the chances that people from this group are going to meet other people from this group? The chances are pretty low. They're probably going to run into and fall in love with people in this much larger group, which makes it statistically just more likely that this will happen. And the same thing with men. Very smart men tend to marry less intelligent women, just because there are a lot more less intelligent people than there are very, very smart people. 2% of the population versus 95% of the population. So, okay, next slide. So again, this is another example of giving a causal explanation when a statistical explanation will do. Okay, so here's another example of regression to the mean. So apparently Carmelo Anthony of the Nuggets, in his first year in the Nuggets, he did amazing. And then his second year, he didn't do very well, and they talked about him having a sophomore slump. And people speculated, why did Carmelo Anthony have this sophomore slump? Oh, it got to his head. He was doing too many radio talk shows. He had too many girlfriends, and blah, 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 blah. They made up all this stuff. When really there was no cause. It was just a statistical inevitability. And again, I'm speaking too strongly when I say inevitability. It is possible, of course, for him to do just as well his sophomore year as his freshman year, but it is much more likely, if you've done amazing, for you to regress toward the mean and to do a little worse the next year. And similarly, if you've done awful, you'll probably do a little bit better. Now, this chart of regression to the mean has to do with batting averages and different players' batting averages from one season to the next. You'll see here that here's a very talented player. They have, again, talent plus luck. Here's their talent. Their luck ran out a little bit, and here they've gone down. Okay, so here's another classic example of regression to the mean. So suppose that there's this crime wave, a new sheriff is elected, and all of a sudden the crime wave goes down. Does that mean that, and again, post hoc, look, sheriff comes into town, crime wave goes down, the crime wave went down because the new sheriff was elected. Well, is this a causal relationship? Maybe not, maybe not. So suppose that crime was at an all-time high, perhaps the crime rate would have gone down even if no new policies were instituted, no new people were elected. Perhaps it was just a regression to the mean. Again, if the crime wave was really low, a new sheriff is elected, and crime wave goes up, it doesn't mean that the new sheriff caused the crime wave to go up. It could be other factors. It also could just be random fluctuations in statistics. A really, really low crime year is probably going to be followed by a higher crime year. Here's another one. So this is a true story. In England, I believe, the authorities went around and posted cameras at the intersections with the highest rate of traffic accidents. What happened? Well, the next season or the next year, the number of traffic accidents at those intersections went down. Now, what did the authorities conclude? The cameras caused the less traffic accidents. So the rate of traffic accidents went down in those intersections because of the cameras. But really, did the cameras cause the traffic accidents? Well, maybe. But But if you look at regression to the mean, if you go and pick out the intersections that have the very highest rates of traffic accidents, statistically speaking, what's going to happen is the accidents are going to go down at those intersections. It does not mean that the cameras caused it. You would have to follow the number of accidents at that intersection for a longer period of time than just 1 year. In addition, you could go around and put traffic cameras at the intersections with the lowest number of accidents and see what happens. What would happen if you picked out the corners that have the lowest rate of traffic accidents is the lowest incident of traffic accidents? The number of traffic accidents would go up, because there's only one way to go but up, there's only one way to go but down here. There we go. Okay. In the Kahneman book, he talks about regression to the mean in relationship to his time in the Israeli army. So Kahneman was teaching about how praise motivates people better than punishment. And the drill sergeant said, don't tell me that. Don't tell me that praise motivates people more than punishment. And then he told the story. He said, whenever a pilot does really well, I praise them. And you know what happens? They do worse the next time. And whenever a pilot does really poorly, I yell at them. And you know what happens? They do better the next time. So the drill sergeant concludes, again, post hoc fallacy. First I praise, then they do better, then they do worse. Therefore, my praise makes them do worse. Therefore, my praise caused the pilot to perform worse. First, I yell at the pilot, then the pilot performs better. Therefore, yelling, punishing, causes the pilot to do better. And this applies in all sorts of ways. Online, there's a basketball coach talking about how he used to believe that yelling at his players made them do better, because he bought into this kind of post hoc fallacy that was fueled by regression to the mean. But what's really going on is the drill sergeant's yelling making the cadets do better? Is the drill sergeant's praise making them do worse? No, not at all. It's just regression to the mean. So if someone does really, really well, so well that it calls the drill sergeant's attention to it so that he'll praise it, that person has only one way to go, but down. They would do worse the next time. If someone does really, really poorly, they probably won't make that mistake again. They will probably do better the next time. So there's luck in a lot of our performances. Bad luck, our attention slips. What Kahneman points out is that this is a regression to the mean, and it's not the drill sergeant yelling or praising that's causing anything here. Okay, so that concludes our discussion of regression to the mean. There's a great discussion of it in chapter 17. It's a really useful phenomena to grasp. There's great application here. So on YouTube, it was the Olympic volleyball coach who actually coached like team basketball, who said that he's realized that regression to the mean, it's changed the way that he's coached his basketball players. So he's realized that when a player misses a free throw shot, and he punishes them by putting them on the bench, and then the person does better the next time. That doesn't mean that him putting them on the bench and punishing them is what caused the player to do better the next time. So this is a good thing to keep in mind. It's also good to keep in mind that we, as humans, one of our psychological biases is to over-attribute causation. There are more coincidences in the world than we think that there are. In the last section of this class, we're going to talk about coincidences and fate, and that'll be really fun. So until then, see you later.